This video is on the transformation rotations. When we rotate an object, we change the coordinate around. So if you notice here, we have inverse, 90 degrees clockwise, 180 degrees, 270 degrees clockwise versus counterclockwise. Notice these coordinates are just rearranged. So a couple of things to think about. If you have a circle, we know that clockwise goes this way. So if we have 90 degrees clockwise, that would be approximately right here. 180 degrees clockwise, remember going this way, would be approximately right here. 270 degrees would be approximately right there. And then, of course, if we got all the way back here, this would be 360 degrees. Counterclockwise would go this way. So we could say this was clockwise and this was counterclockwise. So these yx and negative yx, negative x, negative y. So if we take all these here, etc., we are going to use these kind of formulas in order to change around the coordinates. The inverse of a function, so up here we have the inverse of a function, is this formula here. Sometimes you may see the directions as reflect across y equals x. Okay, so across the line y equals x. So if you see the graph inverse, this is what the coordinate would look like. And if you see something that says reflect across y equals x, you still do the same thing with the coordinate. Okay, so it doesn't matter either way that it's worded. So here's an example. Here's what it might look like. The original point right here is 4, -2. So if I wanted to take this coordinate right here and rotate it 90 degrees clockwise, I need to rearrange this coordinate in the format of y -x. So right now my coordinate is 4, -2. If I want to take these numbers and change it into this formula, I'm going to arrange my coordinates so that my y value is first. So my original coordinates are here. My y value is -2, so I would put that first. And then the formula says next we want -x, which means to take the opposite of x. So if I look at my original coordinate, it's 4, and if this formula right here is y -x is telling me to take the opposite of x, I'm going to write -4 here. So if I were to graph this on the coordinate plane, -2, -4, on the graph, if we go over here, if we went to -2 and then -4, I'm going to have our spot here. That point is rotating 90 degrees clockwise, and it would come right here. So all the formulas work the same. So again, if this is 4, -2, and that's my original coordinate, and I wanted to rotate 270 degrees clockwise, I'm going to take these numbers, 4, -2, and I'm going to switch them around so they look like this, -yx. So the first part of the coordinate says to take the opposite of y. So I'm going to look back at my original 4, -2 coordinate. My y is -2. So the opposite of -2 is +2. So here's my +2. And then I have to write my x. So I go back up to my original and I see that my x was 4. So I come back and write that as this coordinate. So these two numbers here, 2, 4, are my rotation of the point 270 degrees clockwise. So we could also go over here and plot those. So we go 1, 2, and then 1, 2, 3, 4. And this would be my point 270 degrees clockwise. Now when I graph them, I do it the same way that I always have. So just like we said, over 2, up 4. And this is the formula -yx. So we're just going to switch around our numbers and then plot it on our graph. Similar problem is 180 degrees. And for this one, we have -x, -y, so opposite x, opposite y. So I'm going to write my new coordinate. My original was 4. So if I take the opposite of 4, that would give me -4. And opposite of y, if I had -2, so the opposite of y would be +2. So I added a couple labels on here. Here was my original. Here's our 90 degrees clockwise there, which we have labeled up here as well. Here's our 180 degrees, and we have it labeled. This is our 270 degrees point. And then notice for the inverse, you literally just flip your x and your y. So it started out as 4, -2. The inverse would be -2, 4. So I just plotted that point on here too. You'd go over -2 and up 4, and this would be your point there. With the rotations, for most of them, you'll be given shapes. So you'll have to you'll have multiple coordinates that you'll have to plug in for whatever formula it is, depending on how you're rotating your image. So if I'm giving you this shape right here, so it's a quadrilateral, 4-sided shape. Here are the coordinates. You can see them listed here. They were already given to us. So we have -1, 2, 2, 5, 5, 3, and 1, 1. What I have here is this table, and this table is just a way to organize your new coordinates. So the first part of the table, are just your original coordinates right here. These are original coordinates. So I'm just showing you that I just write down my original coordinates, which is what you would do as well. And this is just to help you keep organized. So I'm using the -x, -y formula for this one because we want to rotate 180 degrees. So instead of working from my picture, kind of how we did yesterday with the reflections and translations, for rotations, I'm going to work with my coordinates and then go to the coordinate plane after. So my original first coordinate is -1, 2. So I'm going to take the -1, 2, and I'm just going to transform it by using this formula here. So my new coordinate is going to be the opposite of x. So my original is -1. So the opposite x would be +1. My original y is 2. And this one says to take the opposite of 2. So this would be -2. Okay, my next one is 2, 5, and the opposite of 2 is -2. And the opposite of 5 is -5. So we're going to have that as our next one. Our next one is 5, 3. So the opposite of 5 is negative 5. And the opposite of 3 is negative 3. And then for our last one, we have 1, 1. So again, the opposite of 1 would be negative 1. And the opposite of 1 is negative 1. So once I have transformed all of my coordinates using my negative x, negative y formula, then I'm going to graph it. So we're going to go through and just plot each of these points. So I'm going to pause right now, and you can go ahead and plot these points on your graph and label them. So notice in our rotations, the size didn't change, the shape didn't change. I literally just took these coordinates and rotated them 180 degrees. So our negative 1, 2 rotated down here to 1, negative 2. Our 2, 5 rotated 180 degrees down to negative 2, negative 5. So that's a 180 degree rotation, and you're just rotating all of those points 180 degrees, which is what they had asked us to do. Here's another example. Same idea, just in another different example, and for this one we're rotating 270 degrees counterclockwise. So this is the formula that we'll be using, y negative x. But before we can use this formula, we have to find our original coordinates. So I started off, the first one would be 0, 0 here, and we've got to go through and find all of these original coordinates. We're going to set up a table just like we did on the last one, and I put my first coordinate here. So I'm going to pause the video and let you find these coordinates and fill out your table. And then after we get all of that, then we'll start to plug them into this formula. So go ahead and do that now. So hopefully you found all of your original coordinates. You should have gotten 0, 0, 4, 0, which is right there, 4, negative 3, 1, negative 4. And now that we have our original coordinates, we have our table set up. Now we can apply this formula here. So the formula tells us to take our y and place it as our first coordinate, and then negative x. Well, our first value is 0, 0. So if you take 0 and you put it first, that's actually not going to change that one at all. So we would still have 0, 0. But if we look at this next one, if we take our y value and put it first, then we'd have 0. And then it wants us to take our x value, which was 4, and make it the opposite. So in this case, it would be negative 4. Go ahead and see if you can do these last two here. Okay, so just to check our answers, you should have gotten 0, 0, 0, negative 4, negative 3, negative 4, and negative 4, negative 1. Our next step is to actually plot these points on the graph to see our rotation, our counterclockwise rotation of 270. So go ahead and plot those points on the graph now. So here's our points plotted on. We had 0, 0, 0, negative 4, negative 3, negative 4, and negative 4, negative 1. Notice that our shape still looks the same. Sometimes it doesn't look like your shape was rotated much, but you have to remember this is rotations, and you have to look at what your rotation was. So in this case, we rotated 270 degrees counterclockwise. So even though it looks like it's kind of close, you have to remember this was our pre-image, and we rotated it counterclockwise 270 degrees, and that's how we ended up with our image here. Hopefully yours turned out the same, and check out your points over here too. Make sure everything matches up. And that's rotations.